Last time, we learned all about kinematic diagrams. We built 3 different 2-degree of freedom manipulators, drew their kinematic diagrams, and then learned about how to label those kinematic diagrams, including drawing frames on them according to the Denevitt-Hartenberg rules. In this video, I'm going to show you how to set up PSOC Creator to be able to control the angles of the servos. We'll test it with the last 2-degree of freedom manipulator that we built in the last video. Start today by opening up PSOC Creator. Then click on File, Open, Project Workspace. I want to open up the workspace that we've been working on in previous videos. So I'll start by finding the directory where I saved that project. When you find a file that is identified as a PSOC Creator workspace type, that's the file that you want to open. That will open the workspace as well as all of the projects that you've created inside of that workspace. So for example, when I open up my workspace, I have 2 projects in here. The introduction project that we built in the introduction or preliminaries section of this class, and the LCD example that we set up last time we worked with PSOC Creator. I'm going to go to File, New, and create a new project. This time with my target device, it comes up with the last used device, CY8C5888LTI-LP097. That's what I'm going to choose, and then click Next. Empty schematic. And now I'm going to add this project to the workspace, and I'll call this Servos. And then click Finish. Notice that my project Servos was added to the workspace and it's in bold, indicating that this is the active project. To try and clear things up here, I'm going to close all of the windows that are grayed out. This will make it easier for me to not accidentally change a project that is not the active project. I only want to be making changes to the project servos. Let's build some code here to control the 2 servos that we have built in our manipulator. Servos are controlled with a kind of a signal called pulse width modulation, or PWM. When we get to the motion control part of this class, I'll be teaching you more of the details about how PWM works. For now, I'm just going to show you how to set it up for servos. Click on Digital, and then Functions, and find the entry called PWM. Drag one of those to your screen. When I zoom in, you can see that there are 2 inputs here, clock and reset. There are 4 outputs, but the only 2 outputs that we're concerned with here are PWM1 and PWM2. Scroll down in the component catalog and open the System menu. Inside the System menu, you will find a clock. Click and drag a clock to the screen, and then line up the squares here and let go, and the clock input will be connected to the clock. If you now drag the clock away, you'll see that they're connected by a wire. If these 2 things are not connected by a wire, you can make them connected by using the wire tool. You can click on 2 different inputs or outputs with the wire tool to make them connected with the wire. Now scroll up to inside the digital menu. There's a sub-menu called Logic. Scroll down and find Logic Low. Drag a Logic Low to the screen and connect it to the reset input. Next, scroll down to the Ports and Pins menu. Get a digital output pin, just like we did with the LEDs in the introduction. Connect one digital output pin to each of the PWM outputs. Now, double-click on pin 1 and we're going to change its name to Servo 1. Then change the name of pin 2 to Servo 2. Now double-click on the PWM1 block. Here is where we can set the settings for the PWM. Notice that right here it's telling us the period of the PWM. Again, we'll be learning much more about this when we get to the motion control part of this class. For now, I just want to tell you that we want to get this period value to say 20 milliseconds. Right now it says 21.333 microseconds. To make this period value slow down, one of the things we need to do is slow down the clock. Double-click on the clock and instead of 12 megahertz, change this to 3 megahertz and click OK. Now double-click on the PWM block again. Change the resolution of the PWM to 16 bits. Then, in the period number, enter 60,000. You'll see that the period becomes 20 milliseconds, just like we want it to be. Set the two compare values to 0, and now we're set up to control our servos. Click OK. Next, we want to open up the Pins menu. Click on Pins here, and then double-click on it to open up the pins. Here's where we get to set which pins we're going to connect our servos to. Click on the Port drop-down list, and we're going to pick some pins. Let's make Servo 1 be connected to pin 17. And let's make Servo 2 be connected to pin 16. Next, we're going to write some code. Find the main.c file and double-click. We'll clean up this code a little bit by deleting the comments and also the cy global int enable line. Now before I write any code, I want to build this project and make sure that everything's okay. I'll expand the output window a little bit so that we can see if we get any errors. Then I'll click on Build and Build Servos. Servos is the name of the project. Now I'll wait until the build is finished. Down here, when it's done, it will say Ready. The build finished and it says that the build succeeded. So that means that I don't have any errors in my code. Let's write some test code to move the servos around. Inside main, the first thing we need to do is start the PWM block. I'm going to type PWM1 start. Then inside the for loop, I'm going to write some code to change the angle of servo 1 and servo 2. The function for changing the angle of a servo is called right compare. If I do right compare 1, we'll be changing the angle of servo 1. If I do right compare 2, we'll be changing the angle of servo 2. Now, I know that for our servos, The most clockwise position is achieved by writing a value of approximately 1500, and the most counterclockwise position is achieved by writing a value of about 6900. So those are the two values we're going to test right now. I'll make some comments here to help us remember what it is that our code is doing. After servo 1 moves clockwise and then counterclockwise, I want to do the same thing for servo 2. I'm going to copy these 4 lines of code and then paste them down here. To move servo 2, I only need to change this number here, right compare 2 instead of right compare 1. This will move servo 2 to the most clockwise position. Then if I change this to right compare 2, this will move servo 2 to the most counterclockwise position. Now let's test this code. This is the 2 degree of freedom manipulator that we built last in our previous video. And this is the circuit that we built to control the LCD screen. In this circuit, we've already set up a power rail and a ground rail. That's what we're going to use right now to control the 2 servos. Later on, we'll give our servos more power by using our external power supply. But for now, the power provided by the PSOC will be enough to at least test our circuit and our code. Your RC servos each have 3 wires: a black wire, a red wire, and a white wire. The red wire should be plugged into the power rail, and the black wire should be plugged into the ground rail. Use some of your male jumper wires to do this. I'll take this wire and plug it into the black wire of the servo, and then plug the other end into the ground rail that we set up on the solderless breadboard previously. Next, I'll use another wire to connect to the red wire of the servo and connect that to the power rail of the solderless breadboard. I won't yet plug in the white wire. We'll do that last. I'm going to hook up the other servo the same way. I'll plug a wire into the black wire and then the other end into the ground rail. Then I'll plug a wire into the red wire and into the power rail. Next, take the USB cord that's plugged into the PSOC and plug it into the USB port of your computer. Your LCD might start counting up because that's the last code we downloaded onto the PSOC. Now, let's program the PSOC with our new code for moving the servos. After the program finishes, you might still see a number on your LCD screen. That's because we didn't clear the screen in our current code. And that's okay. We might use this LCD screen later on. For now, we're just going to try and move these servos. So we've already programmed the PSOC with our code. The last thing we need to do to make this work is plug in the 2 white wires. To do that, we need to remember which pins we selected. Servo 1 is pin 17 and Servo 2 is pin 16. So I'll find the cable that's coming from the first servo, the one that's attached to ground. Then I'll use a wire to connect to its white wire and plug the other end into pin 17 on the P-sock. When you do this, the first servo should move between its most clockwise position and its most counterclockwise position every 2 seconds, but then wait for about 4 seconds while servo 2 does its motion. But servo 2 isn't doing its motion yet because we haven't yet plugged it in. Let's do that now. Take another wire and find the cable coming from servo 2. Plug this wire into the white wire for the servo 2 cable, and then plug the other end of this wire into pin 16 on the P-sock. If this is the kind of motion that you get, it's behaving the way it's supposed to. Now, right now, we're just going between the most clockwise and the most counterclockwise positions. I'd really like to be able to type in an actual number of degrees and have the servo turn to that number of degrees. To see how to do that, let's go back to our code. To make this action stop happening, for now, I'm just going to disconnect the USB on the P-sock. That will cut its power and make our articulator stop moving. In order to be able to write an actual number of degrees to our servos for their angles, we need to do a little bit of algebra. Let me show you what I mean on this plot. I'm going to draw an x-axis and a y-axis. I want to be able to input a number of degrees for an angle, and I want to output the right compare value. For servo 1, the most clockwise angle is defined as 0 degrees, and the most counterclockwise angle we're defining as 180 degrees. We know that the most clockwise angle corresponds to a right compare value of about 1500. So I'm going to draw a dot on my plot at 0, 1500. We also know that the most counterclockwise angle corresponds to a right compare value of around 6900. So I'll draw a dot on my plot at 180, 6900. These 2 points on the plot define a linear relationship between the degrees of the servo angle and the value that we write compare. This is my y-axis and this is my x-axis. I want to write an equation for this line, but before I do that, I want to give variable names to these values that I've plugged in so that we can easily change these values in the future. I'll call this value the min angle, and this value the max angle. This value here I'll call the min comp for compare, and this value up here I'll call the max comp for maximum compare value. Now, using these variables, could we write an equation for this line? Perhaps the easiest way to do this is to use something called the two-point form of the equation of a line. The two-point form looks like this. In this two-point form, one of these 2 points is defined as x1, y1, and the other point is defined as x2, y2. Let's plug into this formula the min angle, max comp that we already identified. I put an underscore between min and comp because that's how we're going to type it into our code. This equation says y minus min comp is equal to max comp minus min comp divided by max angle minus min angle times x minus min angle. We're going to go and write this now into our PSOC code. In main.c, instead of entering 1500 or 6900 for these numbers, I would like to be able to put in a number of degrees. In order to do that, we're going to write a new function. We've already used some of PSOC's built-in functions like cy delay and write compare. We're going to create our own function now. A function is any kind of a piece of code that takes some input and gives some output. We want to write a function that will take as input a number of degrees for a servo angle, and it will give back the number that we need to write to the compare in order to set that angle. We want to write our function above the int main function, not inside of it. We start out by declaring the function. This is a word that tells what type of value the function will return. Since we want to return this compare value, our return value is going to be an integer. Next, we need to give the function a name. This is some keyword that we'll use to call the function. I'm going to call this function theta1. Next, we say what kind of value is going to be given to this function as input. We have to say what type this value is going to be and also what it's going to be called. I want to be able to give this function a value that has a decimal. And in C, one of the kinds or types of values that has a decimal is called a float. Float stands for floating point, and it just means a value that has a decimal point. Now I have to give this variable a name. We'll call it angle. Now, just like the main function is enclosed in curly brackets, my new theta1 function also needs to be enclosed in curly brackets. So I'll do an opening curly bracket and a closing curly bracket. Inside this function, I'm going to create a new variable called int compare. Compare will be the value that I want to write here in my compare function. Now I'll use the equation that we derived before to convert the value angle into the value compare. As a reminder, this is the equation that I'm going to write. Y is the new variable compare that I declared, and X is the new variable angle that I declared. I'm first going to add the value min comp to both sides of the equation so that I have Y by itself on the left. Then I'm going to type this into my code. I'll be careful to use parentheses to make it unambiguous what order I want these operations to be done in. Now I've used some variables here that I haven't declared. Min angle, max angle, min comp, and max comp. So I need to go and declare those up here. Besides declaring the variables, I can also give them values. Remember that in our plot for theta 1, we wanted the min angle to be 0 degrees. And we wanted the max angle to be 180 degrees. The min compare value we said was about 1500, but we don't know that value exactly. The max compare value was about 6900, but again, we don't know that exactly. It's just a good place to start. The last thing we need to put into this function is what value we want to return. In other words, we've already calculated the compare value, but we haven't indicated that that's what we want to give back when we call this function. So the last thing we'll type is return compare. Now, let's go down and test this. In right compare 1, which is the function where we're setting the angle of the first servo, instead of 1500, let's type in the name of our function, which was theta 1, and then in parentheses, the number of degrees that we want the servo to go to. Because we made that value floating point, it's good practice to put a decimal point into the number. Here, we'll call theta 1 180 degrees. Let's program the PSOC and watch what happens. For now, I'm going to take the cable that goes to the second servo, and I'm going to unplug the white wire. That will make it so that only the first servo will move after I program the PSOC. I'm also going to make this nice and straight here so that we can more easily see what's happening with this first servo. Then I'll plug in the PSOC. And our old code is running, and I want the new code to run, so I'll click on Program the PSOC. The servo should be doing the same thing it was doing before, rotating between the two angles. Now I would like it to be rotating between being straight along with this line and being straight along with this line on the other side. The reason that I want that is because I'm defining X and Y axes already on my board. This is the X0 axis, like we had in our kinematic diagram. And this right here is the Y0 axis. So I want it to be that when we turn to 0 degrees, it lines up with this line, and when we turn to 180 degrees, it lines up with this line over here. The first thing I'm going to fix is the fact that it goes way too far at 180 degrees. At 0 degrees, it's pretty close to lining up with X0. So, to fix this, I'm going to go up here to the theta 1 function, and I'll reduce the max comp. Instead of 6900, let's do something more like 6500. And then I'll click on Program again. That's much better. Although when it lines up with the X0 axis, I think it's not quite far enough. I want it to rotate farther clockwise. So instead of 1500, I'm going to do 1400. We'll program the PSOC again. Oh, 1400 is too far. I like 1500 better. Let's go back to 1500. Let's try 1450. We'll try splitting the difference. I think that looks pretty good. Let's do the second servo. I'll unplug the PSOC. Then I'll take the theta1 function, copy it, and then paste a copy underneath. This function I'll change to be called theta2. This will be the function for converting the angles of my second servo. Now recall that we want the second servo to turn between -90 and +90 degrees, not between 0 and 180. So here's how we fix that. We change min angle to -90 and we change max angle to +90. Then down here, instead of writing 1500, let's write theta2, that's the new function we created, and we'll put 0.0 in parentheses, that's the angle we want theta2 to turn to. And then here we'll do theta2 +90, and actually up here I didn't want this to be 0, I wanted this to be -90. There we go. I'll plug in the USB cable to the PSOC. And then program the PSOC. In order to get the second servo to actually run, we need to plug this cord back in, right there. Now, when my second servo goes to -90 and +90, I want its -90 angle to be nice and straight, like right out here, and its +90 to be nice and straight. It looks right now like its -90 angle is going too far, and the +90 angle is going not far enough. So I'll go up to the theta2 function, and I want the positive angle to go farther. So instead of 6500, let's try 6600. And to get the -90 angle to go not quite as far, let's do 1500. The negative 90 angle from my Servo 2 looks pretty good now, but the positive 90 angle is still not quite far enough. I'll change this to 6700 and try again. Still not quite far enough. Why don't I go all the way back up to 6900? There we go. It turns out that 1500 and 6900 is right for my Servo 2. It looks like my servos are doing a good job of going between their clockwise most and counterclockwise most positions, and they're correctly named 0 and 180 degrees and negative 90 and positive 90 degrees. So this is a great setup for the next step we're going to. Leave this manipulator built because we'll start with this manipulator in our next video.